Hello everyone, welcome back to Cambridge Guru. We are doing ASA level 9709 paper number 32 series, and this is the last chapter that we are doing, which is the complex number. And we have completed 6 lectures I think in this series, and the last video was about we were doing some examples on set of points in a complex plane. In this video we will see that how we can plot certain points using the argument form, right? So for example, it says that in an Argand diagram showing the set of points z for which argument of z is pi by 4. So as you know that this is our imaginary axis, this is our real axis, the horizontal one. We have to plot the point for the complex number z such that its argument is equal to pi by 4. So pi by 4 means 45 degrees. So this z is moving in such a way in this plane that it should maintain this argument with the positive axis, means the real axis. Okay, so this complex number will be like this. Okay, this is your z, and it is extending like this also. Means from minus infinity it is coming out like this, right? Because this is also making an angle of 45 degrees with the x-axis, right? So this is your z. Next is first part. Second part says that argument of z minus I is pi by 4. So minus I means this simply means that argument of z where the starting point is 0. Okay, so what I was saying that you can extend this is not the case. We have to look for the starting point which is in the first part as 0, right? So basically it is written like this, that it is argument of z minus 0, right? The starting point is z. This can lie anywhere on this straight line, and means finishing point could be z and starting point has to be 0. So from 0 we have to maintain the angle as 45 degree, right? In the second case, the starting point is I. This I means this is a complex number whose real part is 0. So basically we are talking about a point which is 0, 1, and 1 means the imaginary axis it is lying on the imaginary axis. So let us say this is your 0, 1 point or the 0, I point. Okay, and this has to maintain an angle of pi by 4. So second part answer is this one, that it is just shifted 1 unit in the imaginary axis, because means just the center has shifted, right? And third case is that if inequalities are involved, we have to show some points such that the argument should be less than pi by 4 and should be greater than 0, and your center is I, right? Starting point. So starting point in this case will remain I. Okay, and argument should be greater than equal to 0 and should be less than pi by 4. So you will get range of values of x, right? And you have to shade the region. So this shaded portion indicates that argument is greater than 0, right? Greater than 0 means again the horizontal axis, the angle should not be below this parallel line to the x-axis, right? So it should be greater than 0 and it should be less than pi by 4. So you will get a region for this. Okay, so this is for your third answer. So all these complex number which are satisfying this inequality will lie within this region and on these straight lines also. Okay, because equality is there. Okay, if equality is not there, it is just a pure inequality, then you will draw the dotted line that equalities means these straight lines are not involved. Okay, but in complex number a question seldom comes that we have to draw a dotted line. Okay, but if it comes, then you will draw a dotted line for sure. Next example says that we have to solve this equation giving your answer in the form of x plus I. Remember that this is now a quadratic equation in whose coefficients are complex. It is not the thing that since we have included the variable as z, then that's why the equation is complex. No. Okay, but I'm saying that coefficient of this means what is the general definition for a complex number is ax square plus bx plus c is equal to 0, right? and we say that the roots are given by minus b plus minus b square minus 4ac under root over 2a. This is the general formula for the roots of a quadratic equation, right? This plus minus will indicate that the complex root, if these x1 comma x2, whatever are the roots of the quadratic equation, if the coefficient of this complex numbers are real, the coefficients of this complex number are of this equation are real, then we say that the complex roots occur in conjugate pairs, right? That then only we can say that if one root is minus b plus this value, then other root will be minus b minus this value. This we can only say when the coefficient of this quadratic equation are real. Coefficient means this a, b and c, all these must be real numbers. But in this equation we have 2 root 3 I times z. So coefficient of this term, middle term, is not a real number. Why I am saying this? Just to explain this point that complex roots occur in pairs only when coefficients are real numbers. Meaning for this question we won't get complex conjugate roots. We will get some roots which may be real or conjugate, or real or complex, but those complex roots may not be conjugate of each other, right? So let us see, and formula we can use the same formula, right? This formula of solving a quadratic equation, whether the roots are real or complex or whether the coefficients are real or complex, it applies everywhere else for each and every quadratic equation, right? So using this formula and putting the values of a, b and c, we get the roots as minus b, which is minus 2 root 3 I times, because b value is root 3 I, plus minus b square means 2 root 3 I whole square, b square, minus 4, a is 1 and c is again minus 4. This is b square minus 4ac root divided by twice of a, which is a value is 1, okay, in this equation. Now simplifying this, we get minus 2 root 3 I plus minus this square is 2 square is 4, root 3 square is 3, so 4 into 3 is 12. Then we have to square this I square, so I square is minus 1, so basically this value is minus 12, okay. This is minus 12 and this is plus 16 because this is minus 4, so this is plus 16, so 16 minus 12 is root 4 divided by 2. So minus 2 root 3 I plus minus this is 2 divided by 2. So now the roots are x1 is, you can cancel this 2 from numerator and denominator, you will get 1 minus root 3i, 1 minus root 3i, and second root you will get as minus 1 minus root 3i. As you can see here, both the roots are not conjugate to each other. Conjugate roots occur like this, that if it is 1 plus I root 3, then second will be 1 minus I root 3. The only difference lies in the sign of the imaginary part. Real part should be same, but here imaginary part is same, but the real part is different in the sign only, okay. So we won't say that these are conjugate roots. Reason is that coefficient was not a real number, okay. So this fact you should remember. Fine. So these are the roots, and it says that we have to explain giving your answer in the form of x plus iy. So we have given in the form of x plus iy, where value of x is 1 in this case, second is minus root 3. Okay, second part says that sketch on Argand diagram showing the points representing the roots. So now we have to plot these points. Okay, so one point is 1 minus root 3i. This is, let us say, 1 and minus root 3. So x is 1 and minus 3 is somewhere here. Yes. Okay, this distance is 1 and this distance is root 3. Okay, so this is your point. Second root is -1 minus root 3. So -1 distance you will take, it will be just in the negative side, reflection along the imaginary axis. Okay, -1 and minus root 3, right? So these are the two roots. Let us say this is your root 1 and root 2, z1 and z2. Okay, this is your origin. All right. Sketch on it showing the points representing the roots. This we have shown, and you can draw these, you may join these also. Okay. Now it says that find the modulus and argument of each root. All right. So if z1 is 1 minus root 3i, that means its modulus will be 1 square, which is 1, and root 3 square under root. Okay, so this you will get as 2, and z2 mod is also 2. Okay, so basically this distance in the Argand diagram is 2, right? Then it says in the fourth part, an argument also we have to find out. All right, argument of z1 is tan inverse minus root 3 over I. So principal value will be 60 degrees or pi by 3. So basically this angle, okay, from the positive, this angle is pi by 3. So this angle will be also pi by 3, right? Now it says in the last part that show that the origin and the points representing the roots, these are the vertices of an equilateral triangle, right? So basically z1, z2 and O, these are forming an equilateral triangle. How we can prove this? Right, there are two ways to prove this. One is that you can prove that all the three angles are of 60 degrees. This we can say that if this angle is 60 degrees, if this is 60, this is 60, and whole is 90, right? This whole angle is 90 and this is 60. That means the interior angles are 30 degrees each. Okay, means I'm calling up this angle. So this is pi by 6. This angle will also be pi by 6. So whole angle is of pi by 3. Right. Then as you can see that the z1 and z2, they lie on a same horizontal line because the y coordinate is same. If y coordinate is same, that means this angle will be equal to this angle using the properties of parallel lines. This is one concept to prove that this angle is 60 degrees. Right. Parallel means alternate interior angles. Okay, I'm calling this angle and this angle, and this is the transversal. This line is parallel to this line and this is the transversal, so pi by 3, so this also be pi by 3. Similarly, this is pi by 3. Hence, you can say that all the angles are 60 degrees, so this triangle is an equilateral triangle. Otherwise, this angle is 30. You can say that this angle is 30. This you have proved already. If this is 30 and this is 90, so this has to be 60 degrees. Okay, any logic you can apply, or you can prove that all the sides are of length 2 units. Okay, as the modulus of each complex number is 2, means this is 2, this distance is 2, and since this is 1 and this is 1, so this horizontal distance is also 2. So all the sides are equal. So from this also you can say that the sides are forming an equilateral triangle. Okay, fine. Let us do another question. It says that the complex number u is defined by 6 minus 3i over 1 plus 2i. Showing all your working, find the modulus of u and show that the argument of u is minus pi by 2. Okay, it's very easy. I think this we have already done, that whenever there is a complex number in the denominator, we have to bring this in the numerator by multiplying by its conjugate. So we have 6 minus 3i over 1 plus 2i. Okay, multiplying this by its conjugate, so it is 1 minus 2i, 1 minus 2i. In the numerator you will get 6 minus 12i minus 3i, and this is plus 6i square means minus 6, and in the denominator we have a square plus b square, which is 5. 1 square plus 4 is 5. Okay, this 6 get cancelled with this 6, so you get as minus 15i over 5, which is minus 3 times I. Right, so you have been given u, the complex number u, as minus 3i only. So the first thing is this. So it says that showing all your working, we have to find the modulus of u. So modulus of u is just the magnitude of the imaginary part, which is 3, and argument is tan inverse minus 3 by, what is the real part? Real part is 0. So minus 3 by 0. So it is minus tan inverse 3 by 0 using the properties of inverse function. This you should know, right? And minus tan inverse 3 by 0 means this is not defined. Not defined means pi by 2. So argument of u is minus pi by 2 and modulus is 3. Fine. Next part says that for complex number z, satisfying argument of z minus u is equal to pi by 4. Right? So argument of z minus u should be pi by 4. So we have a complex plane. Like this. Okay. Then we have a point of z minus u, means distance of z with the starting point u, right? So starting point is u and we have a complex number z, and it follows a path such that its argument is always pi by 4. So where is u? U is minus 3i, so it is in the negative y direction, means in the negative imaginary axis. This is your minus 3i. Right? Okay, so using this starting point, its distance should always be pi by 4. So this is your complex number z. Okay, meaning this, okay, this angle is pi by 4. So if this angle is pi by 4, this angle is also pi by 4. Okay, this we will see in the next part. Right? Okay, this we have plotted. Now it says find the least possible value of mod z. So mod z, as I said earlier, that mod z means the distance from the origin, right? And we have to find out the least value of this. Least value. So least value of the complex number which is following this path from the origin. So as you will see that if you are taking a point, let us say this minus 3i, resistance is like this, right? But this is not least. As you move closer or along this line, you will get that distances are going to decrease. I show you. Okay, if you plot this, so this distance is obviously closer than this one. Again you drop another line, so this distance is shorter than the previous one, right? And if you start from real axis, so this distance, green one, is less than this distance. Okay, so what I can say is that a moment will arrive when you will get a line which is perpendicular to the line which is following this path. Okay, so this is your perpendicular distance, and this will be the shortest distance of any point, any complex number from the origin. Otherwise all these distances will be not the least distances. Okay, so basically we have to find out this distance. This is your origin, this is P, and this point, let us say, is Q. Okay, now let me, yes, right. So what is this distance OP, we can apply the rule of trigonometries that this distance, this angle is pi by 4, this is 90, so this angle is also pi by 4. I know the distance of OQ, this is 3 units, right? So applying, now we have to find out OP. So in triangle OQP, right angle at P, if I apply sine of this angle pi by 4, so it is opposite, which is OP, upon hypotenuse, which is OQ. Okay, so OP distance we have to find out, and OQ distance is 3, and value of sine pi by 4 is 1 by root 2. So OP is 3 by root 2 units. Okay, 3 by root 2. You can remove this root 2 sign also by multiplying root 2 in the numerator and denominator. You will get 3 by 2 root 2. Okay, so this is your third part. Second part. Third part says that for the complex number z satisfying now this equation, we have to find out the greatest possible value of root 3. So first of all, let us find out this complex number, that u was minus 3i. If I multiply 1 plus I to this complex number, that is going to be the center of this circle. I'm saying this circle because we have already done that mod of z minus something is equal to 1. This is your equation of a circle in complex numbers, in complex plane. Okay, so z minus 1 plus I into u. So let us form 1 plus I into u first, and u is minus 3i. So this will be minus 3i square and minus 3i. This will become 3 minus 3i. Okay, now we have to write z minus this value 1 plus I into u mod equal to 1 simply means z minus 3 minus 3i equal to 1. Right, now we have to represent this in an Argand diagram. Why? Because we have to find out the greatest value and the least value, I think. No, the greatest possible value. Okay, so let us draw another Argand diagram. This represents a circle whose radius is 1 and center is 3 comma minus 3. Okay, so if this is 1, this is 1, 2, 3. This is 1, 2, and 3. So 3 comma 3, let us say this point is your center. Okay, I'm sketching a circle. Okay, let me take a circle. Since I have to take its radius as 1, I should not make it that big. Now it is looking okay. Okay, sorry. Yes, so this is your circle whose radius is 1 unit. This distance is 1 unit from 3 to 2. Okay, and we have to find out the greatest distance. And we have already done these type of questions where you will find the least distance, which is lying along a line if you join from the origin towards this circle, which passes through the center of the circle. Right, so this point will give you the least value, and the point which is directly opposite to this point at the other side of the diameter, this will give you the greatest value. Right, so if you sketch a straight line like this, right, so this value won't be the least value because you have to bring this line to a point where you can find out the least value, and this line will lie along the line which is passing through the center. right? This is what I was saying. So if you draw all these lines, one at that one point is this, one line is this, right, and the last line is this one. Okay, so point P and point Q from O, right? So OP is the least distance and OQ will be the maximum distance. Okay, now let us remove all these points. Okay, something like this, right? So OP is the least and OQ is the greatest distance. And what will be this distance, right? Now as you can see that this horizontal distance is 3 units, this vertical distance is 3 units. So in this triangle O, let us say this point is A and this point is B, it's the center, right? So in triangle OAB, OA square plus AB square is OB square, right? Which is OA is 3, so this is 9, this is 9, and under root is OB. So value of OB means the distance of the center from the origin is root 18, which is 3 root 2, right? And from this 3 root 2, if I add radius of the circle, you will reach a point Q. Okay, if I add this distance, this radius to this OB, you will reach to a point Q, and this will give you the maximum distance from origin, right? So you will say that greatest distance is equal to 3 root 2 plus radius is 1. So 3 root 2 plus 1. Okay. Had it been just the least distance, then you will find out OP by subtracting the radius 1 from 3 root 2. So least distance will be 3 root 2 minus 1. Okay. I hope you enjoyed this video. See you soon in the next video. Thank you very much. Bye.